Well, good morning or evening, whatever time it is that you're watching this. I'm Lawrence Glenn. I'm the Director of Water Resources at the South Florida Water Management District, and I'm happy today to provide you an update of the ecological conditions throughout the Greater Everglades. We're starting up at the Kissimmee, where the Kissimmee River Restoration Project is, and what you're seeing on your screen is a depth map through time. It shows how much of the floodplain is inundated, and you'll see about a month ago, if we look here in this center panel, at 880 CFS, the floodplain was mostly dry. This was because the Army Corps was keeping flow below 900 CFS to facilitate completion of construction for the Kissimmee River Restoration Project, which happened at the end of July, and now in August you see with the increase in flows up to about 1,460 CFS that the floodplain is beginning to inundate. And that's a feature of this project. We have completed construction, and now we go to implement the appropriate hydrology from which we expect to receive those ecological benefits. So as you look at these two different charts that are here on this slide, we're looking at floodplain inundation and we're looking at dissolved oxygen levels. So as I mentioned before, you have flow which has been suppressed. It's been kept below 800 or 900 CFS throughout the past 8 or 9 months, where typically we would come off of the end of the wet season at a higher elevation and have a very slow recession off of the floodplain. What we see in the river channel from dissolved oxygen is that in the summertime when temperatures are higher, it carries less water in the water, less oxygen in the water column, and we're seeing a decline, and a pretty sharp decline, since we've had that implementation of higher inflows. We expect this type of situation to be augmented once that headwaters regulation schedule is in place, because we won't have such a rapid increase of flow during a period of time when temperatures are very high and you can have these crashes in DO as we're seeing now. Moving down into Lake Okeechobee, this is a water depth assessment tool we also use on the lake to look at what stages are across the lake and how that impacts inundation of the marsh. So we have the marsh running around the outer edge of Lake Okeechobee, and as we start to increase stage, which you see last month we were at 12.84 feet in NGVD 29, now we're at 13.72 feet here at the beginning of August, and you see that those reds that are present in the middle of the marsh under those lower stages are now starting to fill. And so what that is doing is we're pushing water back out into the marsh. As water goes into the marsh, we're going to have the resurgence of growth of emergent vegetation. Then the bugs are going to start to come out there to use that habitat. The fish come out to eat the bugs. The birds go out to eat the fish and bugs. So we start that pulse of water back out onto the marsh, and ecological conditions generally follow in a very favorable condition as well. So when we look at stages, we have an updated ecological envelope as part of Recover. What this does is says where should stage be during a particular time of year that best benefits the whole of the ecological makeup of the marsh. And that level runs between about 15.5 feet down to about 11.5 feet. And when water is within, or stage is within this envelope, we say that ecological conditions are best. When we deviate from that, we can start to see negative impacts to the marsh from different ecological components. So if we look at this, we see where are we currently. For 2021, we started significantly higher than we have in the past. And we have a nice recession which is following the same shape as the ecological envelope, but we're out of the ecological envelope until about April. Then we get back in it, but we're at the top. And then when we end up where we are today, we're outside of that envelope again. Now, I'll get to what this all means, but let's take a couple of different years and look at this and see how these different years vary. You'll see 2020 and 2019 both started low, were below the envelope all through the dry season until the wet season. And this was done purposely by the Army Corps of Engineers. If you'll follow the 2018 line, we come down and then we have Hurricane Irma, and the lake filled dramatically. This was also the year that there were large algae blooms within the lake that also traveled to the estuaries. And there was a cry for trying to come up with a way to prevent these blue-green algal blooms from moving into the estuaries. So the Army Corps had a deviation. They wanted to keep the lake lower. They did that, and that prevented the release of water to the estuaries. Now, let's go back now and take a look at, well, what type of impact does that have on the ecology of the lake? So we'll see that during this water year, 2020, water levels were low. And as we look at the ecological envelope, the distance away from the envelope itself can have greater impacts if it's over here in red, or lesser impacts if it's over here in white. But as we move to this next slide, you'll see what was the impact of those water levels on submerged aquatic vegetation. Between water years 2019 and 2020, so we have water year is not a calendar year. It begins in May and runs through April of the next year. Remember that we said that water levels were brought low. So here in this first chart, which we have water years 2019 to 2020, this was that period of low water. And what low water did for submerged aquatic vegetation was that it provided conditions for growth. So you had shallower water, you had clearer water, you had light penetration into parts of the lake where along this fringe where submerged aquatic vegetation grows, we saw a tremendous response. Then in this last water year, we had a very, very wet season. Stages were very high, as you saw where we came out of the graph in the last picture. We entered this calendar year very high at almost 16. So as we move forward and we look and see what that did to submerged aquatic vegetation, is those high water conditions actually decreased light penetration, and we had a subsequent loss of 12,000 acres of submerged aquatic vegetation. So from a vegetation standpoint, those lower water levels were really good in helping regenerate the population from, as you see in this next chart, or can we stop for a second?
Yeah.
I never have to stop.
No
I hate that. Okay.
If it's easier, you want to go, did you just go to a new slide?
I did.
You want to go, if you go back a slide, and then just act as if you're just about to go ahead and
Okay.
cut it together.
Okay. Okay, so where we saw low water levels between the water years 2019 and 2020 that sparked an increase from 5,000 acres to 25,000 acres of submerged aquatic vegetation. Between water years 2020 and 2021, we saw a subsequent decline in acreage by almost 12,000 acres. So low water conditions for a period of time helped regenerate the submerged aquatic vegetation community, whereas if it was very high water levels, which we saw in the subsequent year, it had a negative impact. So this is an interesting diagram that can show you where those losses occurred. And if you're looking at the map on the left, you'll see that there are sampling transects that go from the littoral edge out into the lake, and that correlates with this 12.5, which you see over here on the chart, roughly correlates to the elevation that is this surrounding area right on the fringe of the marsh. And then as you go to the lakeward edge of these transects, you can get into the areas that are deeper. So 8 is actually the deeper part of the lake, and 12 is the shallower part of the lake along the littoral fringe. Now what we're seeing is between the fall and spring of 2020 and 2021, with those increases in stage, we had less light penetration into these deeper areas of the lake, this more center part of the lake, and we had a subsequent loss of that vegetation that was out there. Again, with that depth, we also had a loss of vegetation that was in this elevation between 9.5 and 10.5. So where vegetation was taller, more robust along that littoral edge. That was able to survive through those deeper conditions, but in those deeper areas, the light just could not penetrate and didn't allow for the survival of the different vegetation that had grown out there. Looking at wading birds on the lake, this is a sampling from, it shows us this past breeding year, which is December through June. And what you'll notice is the blue line is the 5-year average from 2016 to 2020. And then 2021 is there by itself. And we have the nesting, or the wading bird use, not nesting, actually foraging, is tracking that same 5-year annual average until we get to February, and there's an interesting correlation here. Then we see a marked spike or jump in use by wading birds. Now, what happened during that period of time is we went from just below 16 feet down to 15 feet, and you see that this is a habitat suitability index, or how much acreage is actually available to wading birds. It increases rapidly in between that stage, and we saw that correlating increase in wading bird use as this outer edge of the lake started to become suitable for foraging by wading birds. We had a subsequent decline during March and April. Our scientists believe at that period of time the conditions were actually better outside of the lake for use by wading birds, which we'll see when we get to the Everglades section of this report. But then in May, the second survey in May, we had a marked increase again, and you can see that right over here. And there's an interesting reason for that. The large increase in wading bird use that we saw in May, or in late May, we found that 60% of these birds that were using it, so 6,000 of the 10,000 birds that were recorded during this monitoring day, were found in Indian Prairie, and in an area of Indian Prairie where the Florida Fish and Wildlife Conservation Commission had conducted a torpedo grass treatment between 2019 and 2020. So what that looked like was torpedo grass grows very dense. You see the pre-treatment on the left side of your screen, and that is a condition that is not conducive to wading bird use. They can't land in there, they can't forage, it's simply too dense. So the FWC came in and did a really nice treatment. You see that open area on the right-hand side of your screen, and what that did was when water levels came to the right condition at about 13.5 feet, it's concentrating prey in this area of the marsh, and these are all great egrets, and they were in great abundance using habitat now that was very useful, opened up nice marsh that allowed for this big spike in wading bird use in this part of the marsh. So moving forward, we use a NOAA product. This is a hyperspectral analysis that picks up the signature of blue-green algae using the Sentinel-3 satellite. And what you'll see is in the beginning of this summer in May, we had an almost entire lake bloom over here in this panel on May 11th. Through the rest of the summer, we've had waxing and waning movement of blooms, increases and decreases, to where in July 4th, in this panel you'll see here, there was a large bloom in the pelagic zone. And as we move to where we are today in August, we have a bloom, but it's mostly around the periphery of the lake with a little bit of a tongue, it looks like, going out into the middle or that pelagic part of the lake. And fortunately, we have a lot of data that we're collecting at the South Florida Water Management District. We've increased our number of stations on the lake to 32 this past year. We also, during the summer season, we increased our frequency of monthly to bi-weekly sampling. So we're getting a lot of data to try to tease out what are the factors that are behind the blooms that we see. Something that's really interesting that we're seeing is dissolved inorganic nitrogen, which is the nutrient that is favored by the cyanobacteria microcystis because it cannot fix atmospheric nitrogen. It needs that dissolved inorganic nitrogen in the water. And there's some really interesting trends that I'll go through here. We'll see that as temperatures start to increase, as turbidity starts to kind of decline, because during the winter we have large wind events that go across the lake, that keep it pretty turbid. But as we get those declines in wind in the summertime, temperature increasing, photo period increasing, we have the conditions that are more ripe for proliferation of blue-green algae. So we've seen that once these conditions start, we see a decline in dissolved organic nitrogen, usually about in May and extending through June. We see that again in the next year with a concurrent increase in chlorophyll A, which is a proxy for blue-green algae biomass. And in this last year, we saw that happen again, but it was a month early. If you go back and you looked at that last slide, you saw that this was happening in May, right over here. Usually starts in about June. So we had an earlier onset of blooms and this large full lake bloom this past year, and we saw that concurrent decline in dissolved inorganic nitrogen with a rapid increase in the peak of chlorophyll A. So something that I'll show you in a couple of slides from now is how the community has changed through time with this decline in dissolved inorganic nitrogen. So looking at the provisional data that we have from our sampling that was conducted in July 21, you'll see throughout the lake we're having a correlation of, or our data is really saying, yes, here is where the satellite is saying the bloom is, and here in the data, you see these red spots, we're seeing over here that we have corresponding high density of chlorophyll A in micrograms per liter. So this tool that we're using from satellite is the data is playing out what we're seeing from space. But something of note, although we have these very higher levels of chlorophyll A, and we have bloom conditions we consider once you increase above 40 micrograms per liter, is that microcystin levels or toxin levels, there's only two that exceed 8 milligrams per liter, which is the EPA's level for public health and safety. So although we have these very high levels or densities of different blue-green algae, we're seeing very low levels of toxin, and that's a positive thing. As we move forward and we look at where does the phytoplankton biomass change within the lake, or where does it occur, where is it most often prevalent, we're seeing that it's really the northern half of the lake that tends to have the red spots, which are the bloom conditions. So this additional data that we're getting, we're able to see, where do they start, how do they change throughout the landscape of the lake, what are the nutrient concentrations that are there in those different areas during those periods of time that might be a factor in helping to drive these blooms. And then here's a very interesting point that I was alluding to, is we're looking at dominant taxa in the upper left-hand table. And you see at the beginning of the year when that large bloom was occurring in May, that at least 70% of the community was dominated by microcystis. As we have gone through the season and that dissolved inorganic nitrogen has declined, we're seeing a decline in microcystis, and we're seeing an increase in mixed communities, and these mixed communities are often made up of communities that can fix atmospheric nitrogen. So this is some really interesting data that we're getting, and we're seeing also with the corresponding change in dominance by microcystin, we see a corresponding decline in the amount of toxin that is in the water. Moving to the St. Lucie estuary, we're looking at, on this top panel, daily inflows to the estuary, and you'll notice that blue is when we have releases from the lake. So we haven't had releases to the St. Lucie since about April. All of the flows that we're seeing currently are coming from either C23, C24, or 10 Mile Creek in the tidal basin, and currently it's about 1,300 CFS. And what that does is it sets up differences in the salinity gradient within the estuary. Here a month ago, before we had the really heavy rains that have caused these higher discharges, you see a different salinity gradient setup than you see in the middle of July. So now we're getting a lot of runoff from the tributaries. We have almost freshwater conditions in the top, which moves to your in between 15 and 18 in the mid-estuary, and this is where most of the oyster beds occur. So we're seeing salinity decline in this panel over here to the side, where we're still within the good range for adult oysters, but it is declining. And if we look at oyster recruitment through this time, so we're looking at spat that is collected on these T sampling bars, which is your upper middle panel. We're looking at how oyster recruitment has changed through the past 3 seasons. 2019 was a good year. It was a very low flow year. This year, we're tracking about where we were last year, and that is with salinity still in the good range for spat recruitment. We look, however, at density of live oysters, and we're seeing a nice increase through time during the reproductive season, and it's almost doubled in those 2 sampling events. Moving to the Caloosahatchee River, we looking at this top panel. You see the contributions from in-lake flow, which is in blue, C43 basin in gray, and from the tidal basin in green. And you'll notice that we've been making, or the Army Corps has been making releases to the Caloosahatchee River from Lake Okeechobee until about July, at what point the rains really increased and the amount of surface water runoff from this very large C43 and tidal basin are what is coming to the Caloosahatchee currently. Out of S79, which is the structure where the St. Lucie River starts right here, currently there's about 2,000 CFS being released. And what you see when we start getting discharges that are in the 2,000 range or above is it changes the salinity gradient, where in June, before the rains had started, the freshwater portion didn't quite make it down to Fort Myers, and now that freshwater portion has moved down past Fort Myers, and it's pushed this oligohaline zone down a little bit further, and down at the bottom, Shell Point, Sanibel, Cape Coral, this is the area where oysters are within the estuary. And so what we've seen with this corresponding change in salinity is we're seeing now with these higher flows, we're seeing a decline in salinity, but it's putting Sanibel back into the good range. Shell Point is also in the good range and is starting to have Cape Coral creep a little bit down towards the fair range. So looking at oyster response to these different inflow regimes, you see that here is Iona Cove. It's up here in this kind of sheltered area, and Bird Island out here in the middle. We're seeing conditions where spat is on the increase, like it does every year. It starts kind of slow and has a jump, and that jump is more substantial in Iona Cove than we're seeing down here in Shell Point, where we're actually having a decline. And what might be happening here is that discharge is high, and it's moving that spat past the reef itself for those oysters to settle. But we're seeing a subsequent, in both places, increase because in live oysters, which is a good thing, and we're seeing that corresponding salinity in the good zone and a corresponding increase in adult oyster live density. Now looking at the stormwater treatment areas, this is really going to the volumes of water that come out of the STAs, or the stormwater treatment areas, is what is delivered now down into the Everglades. You have the Central Everglades, which are the areas 1, 2, and 3, and then down into Everglades National Park. And for the water year 2021, which is in this last bar over here, was very significant in the amount of inflows and releases from the STAs, and that we released 1.6 million acre feet of water to the Everglades. And we're going to see that has a pretty profound impact upon the ecology of the Everglades. But before we get there, we'll stop briefly in Biscayne Bay. And what you see in Biscayne Bay currently is that there is a relationship, an inverse relationship, when we have an increase in inflow into the bay, we have that correlating decrease in salinity. So during this period of time between November and the onset of the rains, we have a decline in inflow and we have an increase in salinity. But since those rains have started, we're seeing a decline in salinity, which is becoming more like what we would like to see in an estuary like Biscayne Bay. Moving down into the Everglades, as we look at, this is another feature that we have at the district, water depth assessment tool. We're looking at what are the changes in water depths through time. And we see from about a month ago, or actually now 2 months ago, in the central Everglades, we were starting to have dry down in the top parts of Water Conservation Area 3, throughout Water Conservation Area 2, and in the top of Water Conservation Area 1. And with the onset of the rainy season, we're seeing those water depths being ameliorated. And we're having connectivity again through Shark River Slough. We're starting to see Lossman Slough fill, and Taylor Slough over here is also starting to reconnect. We go back a year ago, because this is some really interesting data. A year ago, we had that extremely extreme wet season. And so we had a wet season that put a lot of water into the Everglades, such to a point that FWC had to put out an emergency order because the fur-bearing animals were being negatively impacted, and we had water impounding to about 5 feet. Subsequently, we were able to move a lot of that water south. And SERP is coming through, and what it is designed to do is really do exactly what we saw this last year, and that's put greater volumes of water into the Everglades and then have that water move subsequently south. So we see back in February of last year, we had connectivity of Lossman Slough, we had full connectivity of Shark River Slough, as well as in Taylor Slough. And then we had a nice slow recession that allowed these waters to recede, to concentrate prey, and we're going to go through and we're going to see what type of impact that had on wading birds, which was pretty tremendous. So during that period of time in February, where I said water levels were deep, this is a habitat suitability index looking at what levels or what depths out there are most suitable for foraging, and those are the green areas you see here in the middle of this bar. When it starts getting blue and darker blue, it gets too wet. When it starts getting brown to darker brown, it's too dry. So during February, much of the central Everglades was too deep, but the bird use that occurred down here in the coastal region was incredible. 12,000 birds using this coastal area that hasn't seen that in decades. These stars that you see here are the formation of supercolonies starting to occur. As we had this drying out of the central Everglades, those birds increased their nesting along the side and also started to move up to take advantage of where habitat was most suitable for them to forage. So we had large numbers of birds using the Everglades this past year. And when we get to the end of the season, if you look over here at this red bar, this is a conservative estimate of 80,000 nests within the Everglades. It's second greatest year since 2018, which was our banner year of over 100,000 nests. And that's since the greatest nesting success we've seen since the 1940s. Some of the reasons for this real increased nesting success is that we had water levels that allowed for foraging. We had great recession rate, which was long. We didn't have reversals, so it allowed if you look down into this drying pool down here, which concentrates prey, so the groceries of the Everglades for wading birds was highly increased and then brought into these large wading pools or drying pools that then allowed the parents to go and forage successfully to come back, feed their young, and allow them to fledge. So the conditions of increased prey productivity, increased habitat availability, and then foraging depths in the right places and at the right times, along with a protracted or extended dry season allowed for the success of these birds to fledge the nest. And if we look at this picture down here, there are hundreds of wading birds in here, and the larger white ones are white pelicans. White pelicans eat a larger amount of biomass and larger fish. So that's just saying that the prey availability was right, it was abundant, and it allowed for the different species to really get in here, get those groceries, and have success in getting their young fledged. We're going to end up in Florida Bay. And what we've seen in Florida Bay this past year was with that 1.6 million acre feet of water that was delivered down through the STAs and through the Everglades, when we get to Florida Bay, those large volumes of water made it, and they brought salinity levels down below the 5-year interquartile range that we use. I call it the blue brick road, but as long as we are pretty much within that salinity level, we think that the bay is set up nicely from a seagrass perspective and for all of the different components of the ecosystem that are driven by salinity. So we had very, at the end of last wet season, we were, or the 2020 dry season, we were concerned as we were in that dry season that we might have hypersaline conditions. So you can go from one extreme of not having enough rainfall to another extreme of having a tremendous amount of rainfall that took us from almost going into hypersalinity down into a condition where the salinity conditions were pushed very low, but it set us up for a very good wet season. And so here we are, that same time of year, January of 2020, where conditions were very high, approaching 40 salinity units PSU within the bay, to as the rains came and started to freshen as they came through the coastal lakes, and then you see this nice gradient that was occurring at January of last year. What that allowed for was a real boost to the fish community. Tarpon will go up into those coastal creeks and those coastal lakes for having their young. So here we see the juvenile tarpon that were found within the bay in this past year have just gone gangbusters. It's the best they've had in 20 years. And that's because of these salinity conditions that were driven down and allowed these fish to move up into that area to grow and come back, and they hopefully recruit into the adult population. And then I'm going to take you through some amazing pictures of that coastal area. For SERP, one of the performance measures that is used is revitalization of these coastal supercolonies and use of the coastal area by wading birds because of the fresh water that is coming down into that system. So through these panels, you just see incredible wading bird use. You see this on the right side panel, wood stork colony, a large colony in the Broad River. That's a coastal colony that only becomes active when there's a lot of fresh water within the Everglades. And then we see the shorebird use was highly increased as well. And then we come into this enormous flock of white pelicans, skimmers and snakebite, and diving ducks and coots using Garfield bite. So the bird response to these freshwater deliveries was absolutely incredible. I'd like to thank you very much for spending time with me today to go through the ecology of the Greater Everglades. We're happy to meet with you and discuss any attributes of this ecology during the conference. So thank you.